So for UART, we have discussed like what is UART, how it internally works, and for this like we are going to see one experiment. So the experiment, the circuit diagram is one LED is connected and a virtual terminal we are going to use. Okay. So virtual terminal, how to interface virtual terminal, that I will share one video to you guys. But coming to this connection, so what this virtual terminal is like just like your terminal, you have in Linux, we have a terminal, right? So in terminal you can type some commands, type some characters, right? So similarly, if you connect with this virtual terminal and if you run this like a simulator project now, so you will get one window. So in that window you can type some characters. So whatever character you are typing, that character is transferred using this UART protocol. So here using UART protocol, we are going to connect this controller with that virtual terminal. So from virtual terminal, whatever character you are typing, that character will be passed here. So you see here, so from this TX pin, it will be passed and it will be received in the RX pin. So UART is having only one data line for one way of communication. But it has a two data line. You see here, one is from this to like a microcontroller to this virtual terminal sending, and other one is from virtual terminal to microcontroller receiving. Got it, right? So TX is connected with RX, again TX is connected with the RX. So in PIC controller, the RC6/TX we have, RC7/ we have a RX. So here we are not going to use it as a RC6 and RC7, we are going to use it as a this TX and RX. So in UART protocol, if you are using UART protocol, these two channels only is enabled. Got it, right? So like already we discussed, right? If it is a PWM, for PWM there are some channels. For analog there are some channels. For digital there are some channels. Similarly, for UART protocol, if you enable the UART protocol, these two pins will be acting as a TX and a RX pin. So using this TX and RX, you can send as well as you can receive it. One pin for sending, one pin for receiving. Okay, you have to connect vice versa. TX is connected with the RX. You see it properly. So what we are trying to do in this experiment is, in the virtual terminal, you are going to type some character, alphabets. If you type A, that A is received here. If received character is A, means you are going to make the LED on. Next you are typing B. If received character is B, means you are going to make the LED off. This is very simple experiment. What you guys can do, first you do this. After that what you can do, you can connect one LCD. Whatever they are typing, that character you can display it on the LCD. Got it, right? So just I will explain this flow. We'll see. Okay. Circuit connection is everybody clear? The connection is very simple. Just one LED and your virtual terminal is connected. How to take virtual terminal, that I will share one video. Fine. Coming to this program. So here, as usual, these two lines, you guys are clear with it. It's just a header file and the frequency you are setting. And the global variable you are declaring data, it is initialized with a 0, and you have a, what is this? ISR. Okay. So void interrupt, and any name you can give. The name can be anything. So ISR, and here the interrupt is receive interrupt flag. So receive interrupt in the sense, whenever data is coming from in UART protocol, whenever data is coming from some other like a peripheral, some other device, so the data is received in this microcontroller, means then automatically interrupt will be raised. Got it, right? So when data has come, interrupt will be raised, so that controller will the control will come here, and you are checking whether it is a receive interrupt. If it is receive interrupt, that data will be present in the receive REG. Okay, like already we discussed for yesterday we discussed for EEPROM, right? In the EEPROM, EREG, right? Or is a E data, EADR will be there. No? Similarly, for this UART protocol, the receive data will be available in this receive REG. So from that you are putting into global variable data, and then you are making the flag to 0. Then you are going back to your main function. So in main function, here GAE, PEAE you are enabling because any interrupt you have to enable both of that, and along with that receive interrupt also you are enabling, because whenever data is received we want to get the interrupt. And TRIS-B, port B you are making it as a 0 because we are connecting LED. You can directly make TRIS-B 7, port B 7 directly 0. So but here commonly configure the entire port. You can particularly configure the particular channel as well. And TRIS-C is configured as a 0x80. So 80 is which channel we are going to use it for input purpose, which channel we are going to use it for output purpose. Okay, so there which is used for input, RC7 or RC6? RC7 is used for input, RC6 will be used for the output. That's what. So RC7 in the sense 1, 0, 0, 0, rest all will be zeros. Got it, right? Then the equivalent hexadecimal value is 80. Is everybody clear?
Yes, sir.
So even though you are configuring the serial port, you are enabling the UART, but still which is used for input and output, that also you need to configure. That's the reason TRIS-C we are configuring it with the 0x80, that is RC6 is output, RC7 is input. And these three are the actual UART configuration. I will come to this. These three I will explain. Okay. And coming to while loop, in the while loop you see the data you are checking if it is equal to A. It means like when the loop is running, whenever you are typing from the virtual terminal, you are typing character small a, that is received on the microcontroller. Once it is received, the interrupt will come. Once interrupt is coming, control is going here. You are taking that data into the data register, data variable, and your control is coming here. If it is equal to small a, what you are doing? RB7 you are making it as a 1. Else if it is received character is B, you are making the RB7 as a 0. So if small a is coming, you are making LED on, small b is coming, making LED off. It's a very simple experiment, but you can make it according to your need. So you can as I mentioned, like you can display it on the LCD, or you can display it on the 7 segment. You can receive numeric character and display it on the 7 segment as well. Okay, right? So this you are keep doing it, and whenever interrupt comes, going and taking the data, and then according to the data you are doing any one of it. Okay, I think overall the experiment is clear except the configuration. Okay, now coming to the configuration, steps for implementing UART is configure TXSTA and RCSTA. Okay, so coming to TXSTA, in TXSTA whatever is needed only that I highlighted, remaining things I just these are all some parameters are there, but I am not highlighting because I don't want to confuse you people. Okay, so TXEN stands for transmit enable bit. If this bit is 1, then only using like a UART protocol you will be able to send something out. So for that you have to enable TXEN. This bit you want to make it as a 1. And synchronization that we are not using, and this is unused. BRGH. BRGH is nothing but baud rate select bit. Okay. So if BRGH is 1 means it is a high speed baud rate. If it is 0 means it is a low speed. So if it is 1 means you are selecting for 9600. That's a high speed. I think if it is 0 means it is like half of it, 4800 I think. So we want like a 9600, so that we are making this as a 1. So in TXSTA we are doing 2 configuration. One is a TXEN, transmit bit enable you are doing, and other one is like a baud rate you are selecting. So you want high baud rate means you want to make BRGH as a 1. If you make BRGH as a 1, like the baud rate is 9600. Clear? So both are 1. So what is the equivalent hexadecimal value?
0x2.
Yeah, 0x24. Got it, right? That is what we are configuring on the TXSTA. Now Coming to RCSTA. RCSTA is here. In RCSTA also two configuration we are doing. One is SPEN. SPEN stands for Serial Port Enable Bit. Okay. So serial port serial port you are enabling. That's all. Again, you should not think, sir, serial port means like in serial you have UART, I2C, SPA. That's what we discussed in the morning. Correct, no? Serial communication protocols or UART, I2C, SPA. These all protocols are available in this microcontroller. Just we are enabling serial port. That is separate. That is synchronous serial port. Got it, right? I2C and SPA is a synchronous serial port. So tomorrow, the Monday session, you will be enabling SSPEN. So SPEN means it is UART. SSPEN is like a I2C and SPA. Got it, right? Again, within that, how to differentiate that I will tell you later. Okay? So this is synchronous serial port enable. This is serial port enable. So serial port means actually you are enabling only UART, because only UART is asynchronous protocol. Remaining two protocol is a synchronous. So you have to do SSPEN enable. Clear, everybody? So SPEN you are enabling. So by making this bit as a 1, actually you are enabling these two pins. So then this RC7 and RC6 pins will be enabled for the actual UART protocol. Otherwise, like your RC6, RC7 will be used only for the normal like input-output purpose. Got it, right? So by making this as a 1, you are actually enabling your UART protocol. If it is 0, then the protocol itself is disabled. CREN. CREN stands for Continuous Receive Enable Bit. Okay. So continuous receive means like a morning. Say previously we discussed 1 8-bit you are receiving. No. Similarly, you want to receive continuously like a multiple 8 bits. That is also possible by making this as a 1. But anyhow, in this case it is okay. And even if you are not enabling also, it's fine. But for that purpose, this CREN will be enabled. So if CREN is enablement, it is enabling the continuous receive. So now your configuration of RCSTA is this. So the equivalent hexadecimal value is 8 plus 1 is 9. So 0x90. Next, you have to select the baud rate. So already you selected that sir, I baud rate I want. Again in that like actually which is the transmission speed you want to set and the number. So for that you have to use this BRGH, SPBRG, serial port baud rate. Got it, right? Serial port baud rate. So for that you have a formula just like our timer only. In timer, whatever the time delay we want, we are not setting directly. What we are doing, there is a formula. Using that formula, we are setting it by indirectly. So similarly, here also you have this formula. Baud rate is equal to frequency oscillator 16 into SPBRG plus 1. So here baud rate like we are setting 9600. Oscillator frequency is 20 MHz. Only unknown value is SPBRG. If you solve this, you will get the value 129. So that's how the 129 has come. And here, like this, since we are discussing about RCIF and TXIF, so I'm just like added one more register, PIR1 register. PIR1 register. So RCIF will become 1 whenever the receive buffer is full. It means, see, from here you are sending something, here you have a receive buffer, that is RCREG, you have got it, right? So 8-bit data is coming from here to here, that 8-bit data is received here only now. So when the data is filled in this 8-bit, then automatically the flag will become 1. That is, interrupt will be raised and that flag will become 1. So that is what just I want to understand that the flag, how it behaves. I want you to understand. So RCIF is a UART receive interrupt flag bit. UART receive buffer is full. Whenever this, what time this will become 1 is when the buffer is full means this will become 1. When that buffer is empty means that bit, that particular bit will be 0. This is RCIF. And TXIF is, TXIF here we have not used because I am not sending anything from here to here. Only receive I am doing. For receive, for receive only we have written the function. For sending, you are using this flag. So TXIF is a transmit interrupt flag bit. This bit is 1 means your sending register is empty. That is TXREG. Receiving register is different, sending register is different. So your sending register is like a empty means it will be 1. If it is 0 means it is full. This is other way. This and this are like a completely different. When you are sending, see for example, whenever like the data is like for example in the sending register you are putting one data. Let's take like you are putting some capital A. This you are putting here. It will be an 8-bit number. Capital A internally it is ASCII value, no? So it will be 8-bit number. So once you put once this all 8-bit is transferred here, this automatically will become empty. And that particular flag will become 1. So it is indicating that boss I have transferred. See, understand one thing. From here if you are receiving mean that receive flag will become 1. From here if you sent means that sent flag will become 1. Sent means what? That it will become empty. So here receive or send is happening on the shift register. Listen carefully. Whether from one device to other device, you are sending the data or receiving the data. Once it is sent from here to here, you are actually shifting. You are not copying. You have to understand the difference between shift and a copy. So if you are copying means here one copy will be there, here one copy will be there. That is you are copying the data. But in communication protocol, any data from here to here you are sending or here to you are sending, actually you are shifting it. It means one bit from here to here it is sent mean one bit will be reduced here. That bit is removed. That bit only is transferred here. If all 8-bit is transferred here means this register will become empty, this register will become filled. Got it, right? So any way of communication is happening, that's how it is internally happens. That's what the role of the shift register. It is actually shifting it. So now you come here. So when he is sending something means from this it is shifted to here. When this buffer is filled means he will get the interrupt and that particular flag will become 1. So if that flag is 1 means he knows that like that in that register data is there. So he will take the data. Clear? Receive is clear, everybody? Now from here you are sending here. So now here you have one 8-bit register. In this you are putting one data, and that once it is sent completely here means this register will become empty. Once it is becoming empty means what is the meaning? It is sent properly. All 8-bit is sent. So that time that particular flag will become 1. It shows that like boss I have done my job. Clear, right? All 8-bit I have transferred, so that he is making that flag as a 1. So when this TX flag will be 1, if completely transferred from here to there it will become 1. If it is full means still has not transferred, so that it will be 0. Getting right, everybody? Okay. So I think that's all. This is just an extra information, but actual registers are just the TXSTA, RCSTA and SPPRG. Okay, any question? Okay, so just to summarize, the previously like we discussed the concept. Okay, so from one device to other device, you are sending some data, means that is we are calling it as a communication. So communication can happen in two ways. What are the two types of communication? Serial and a parallel. Okay, so parallel means like in one clock all 8-bit or all 16-bit or all 32-bit will be transferred, because you have a 32 line or 8 line or 16 lines. If it is a serial communication, in one clock only 1 bit will be transferred. If you are trying to transfer 8-bit data, then you need a 8 clock. If you are trying to transfer 32-bit data, you need a 32 clock. So as a overall, what is the difference between parallel and serial communication? Which is faster? Parallel is faster, serial is slower. Which is used for shorter communication? Parallel. Which is the serial will be used for the longer communication. Okay, that's fine. Now coming to serial, again in the serial communication there are two types based on the clock. One is synchronous and other one is asynchronous. So clock already we discussed. Since we have a clock line, based on the clock line only, sender is going to intimate the receiver, boss, this time you take the data. Apart from that, like the receiver is going to do his own job, sender is going to do his own job. So whenever sender want to send something, he will intimate on the clock line. Accordingly, like the receiver will get the like understanding. Okay, now the sender is sending some data, so he will take the data from the data line. So this is like a synchronized serial communication. Coming to asynchronous serial communication, no clock, only data line is there. Okay, only data line is there. So here we have two data line, because two way of communication we are doing. You should not again say, sir, you said only one line. This is like from year to year one data line, from year to year one data line. So using data line, how this communication is happening? So far that there are some basic 3 rules. What are that? Start, stop bit, data length, transmission speed. So these all 3 things should be common between these people. Then only this communication is achievable. Now let's take like when from sender to receiver no data transfer is happening, then that state we are calling it as a ideal state. When the ideal state is there, what is the state? What is the like? It will be always I. So it means like the receiver also will be knowing that like no data is coming. Now sender wants to send some data. So that what he will be doing? He will start with the start bit. So it means like from I, 5 volt is going already. From I, like he will send a 0 volt. How long he is sending? 104 microsecond. Why 104 microsecond? The transmission speed is 9600 bits per second. So that to transfer 1 bit, we need a 104 microsecond. So for 104 microsecond, he is sending 0 means the receiver will get alert. Okay, he is given the start bit. So after that, like he will be checking every 104 microsecond, 5 volt is coming or 0 volt is coming. If 5 volt is coming, then the received data is 1. If 0 volt is coming, the received data is 0. So like that, he will be checking for next 8 bits. Why he is checking for 8 bit? The data length of receiver is 8 bit, and he is assuming that the sender also 8 bit, because the basic rule of the communication protocol is both should have the same data length. So that he is looking for the next 8 104 microsecond. After 8 104 microsecond, he is looking for the stop bit. So stop bit is again I. After stop bit, again it goes to the idle state. It means it remains the 5 volt forever till the communication next time it starts. Got it, right? So this we have seen in the programming. So coming to programming, the concept is not there. In programmatically, you are not implementing any concept. You see here, you are just enabling the protocol. The concept what we discuss and program is little different. Here, what you are doing, just you are enabling the protocol. If you enable, internally the communication is happening in the same way. Got it, right? You are not implementing the communication. That is implementation of the communication. So just you are enabling, so that once you enable and any 1 bit data you are sending, internally it happens that way. Before that data what you are sending, it will be always I. When you are sending First he will send the start bit, he will become alert. Next 8 bit he will be sending, that is your actual data. After receiving 8 bit, he will be sending stop bit, and it will come again, it will become to the idle state. These are all internally the protocol itself is taking care. You're not just doing anything, you're just enabling the protocol, you're just using the existing protocol. Got it, right? So for that you are enabling, and the remaining are just like a basic configuration only. So continuous receive you want means you are enabling it, and transmit you want to do means transmit you are enabling, and baud rate. See in this, some are like if you are feeling, sir, is it mandatory or not? If you are little confused, now what you can do, same experiment, first you try whatever program I given, run it, and after that what you do, which and all you are feeling, okay, this is little confusing, I want to comment, sir, continuous receive if I don't enable, what will happen, whether my still project will work or not. Okay, first you disable this you make it as a 0 and check the same experiment, so that you can become okay whether it is working or not. Or if I am sending continuously like a string, okay, here I am sending A and B, right? Instead of that, like I am sending I am sending embedded as a one string. So that time a continuous receive should happen. So that time again you check with by enabling this and by disabling this, what happens, what is the behavior, so that you can become more strong. Got it, right? So like this you can experiment this, and similarly here also BRGH you are making it to 1. If you make it to 0, what happens? First you try it with 1. If you make it to 0, again do the same experiment, set the same baud rate 129 only, you set, you check. If it is not working, then you change the formula like a here 4800, and then you try to get it. Or worst case you are little confused, whatever question you have, put it to ChatGPT. Put clear question, that is very important. Again, using ChatGPT is like, again, it is not that like a it should be a general template. What is your question? See, assume that I am using PIC16F877A. So I am using communication protocol UART, and in this like the particular register TXSTA, the BRGS, I am making it to 0. Previously I configured 1 and I configured my baud rate as like a 9600. Now I am making it to 0. So what should be the baud rate I have to set in the formula. So like this exactly you put your actual question. Stop it.